Hi class, let's turn our attention back to this figure again, the application of sensible heat and latent heat to weather, okay? And so this is where we left off when we were talking about sensible heat. Let's add in the latent heat component to this and see how it goes. So just as a reminder, we have a surplus of heat energy, radiational heat energy at the surface of 30 units. On a global basis, we have a deficit of 30 units of radiational heat energy in the atmosphere, and so we need to transfer that surplus heat energy from the surface into the atmosphere. And so we first looked at sensible heat, so solar radiation heats up the surface, causes the surface to warm, establishes a temperature gradient, and so we transfer heat energy from the surface into a thin layer of air that's in contact with the ground through conduction. That warms that thin layer of air in contact with the ground, causes that air to become less dense and rise through convection. And so some of that surplus heat energy is transferred from the surface into the atmosphere through sensible heat, which is a combination of conduction and convection. Now let's look at latent heat. Okay, so latent heat is energy that is needed for phase changes of water. And so that's the reason I drew in the tree and the corn stalks and the water down here. And of course, I didn't leave myself enough room. But in any case, that's where we're focusing our attention, is right down here. So now trees and crops will transpire. They will take liquid water and convert it into water vapor. And then we also have a water surface here. This could be representative of an ocean, a lake, a river. It could be soil moisture, any type of liquid water at the surface that is going to be evaporated. Okay, and so here we have then water that's represented here, and we are going to evaporate this water. Or we aren't, but the atmosphere is. So we've got evaporation taking place. And remember the energy exchange that's taking place when water evaporates. It's going from liquid phase to vapor phase. And so that requires the absorption of 600 calories of energy for every gram of water that's evaporated. Okay, so where is this water? Where is this heat energy then? So heat energy is being absorbed. 600 calories of energy per gram of water that's evaporated is absorbed, and it's contained in the water vapor. So I'm making little dots here to represent water vapor molecules that's in this thin layer of air that's in contact with the ground surface. Okay, so evaporation converts liquid water into water vapor. Water vapor, these little blue dots that I'm drawing in the thin layer of air that's in contact with the ground, okay, is now going to be, it's going to hitch a ride now, really, is what's going to happen is, all right, so we got evaporation, the absorption of 600 calories of energy per gram. We have the absorption because we have surplus energy at the Earth's surface. Now this water vapor in this thin layer of air that's in contact with the ground is going to hitch a ride with convection. Okay, so conduction and convection created sensible heat. Okay, and evaporation at the surface, okay, is going to absorb 600 calories of energy for every gram of water that's evaporated. That water vapor is going to hitch a ride in convection. And as the air rises, and this is a big part of chapter 6, so you're going to have to take my word for it now. As the air rises, the air is going to cool, and if it cools enough, it's going to reach the point where it condenses, okay, and will form a cloud. Okay, so condensation results when the cloud forms, and that condensation is going to release 600 calories of energy for every gram of water that is condensed. Okay, so really the important thing is here at the surface we had a surplus of heat energy. Some of that surplus heat energy was used to evaporate water, which required the absorption of 600 calories of energy per gram. We converted liquid water into water vapor. Water vapor hitches a ride through convection. And if the conditions are right, that water vapor is going to condense into a cloud. The condensation process releases 600 calories, releases heat energy into the atmosphere, 600 calories of energy per gram. So the long and short of it is we had a surplus of heat energy at the surface. We had a deficit of heat energy in the atmosphere. How do we overcome that imbalance or that inequilibrium? We move that surplus heat energy from the surface into the atmosphere through a combination of conduction and convection, which is sensible heat, and through evaporation and condensation, which is latent heat. Okay, the combination of those two things, so sensible heat is 7 units, moves 7 units of that 30 units of surplus from the surface into the atmosphere. Evaporation and condensation is going to release 23 units of heat energy. Okay, so that's how the Earth atmosphere system transfers that surplus heat energy from the surface into the atmosphere through a combination of sensible heat and latent heat. Okay, evaporation and condensation being the latent heat. So again, this is really cool. And so on a global basis, this is how the Earth keeps its balance, and in the process, creates weather.